Um, Yogesh is a civil engineer, a project management professional, and a member of Royal Institute of Chartered Surveyors. Yogesh has executed complex projects in over 9 countries and has spent a large part of his career in the US executing projects for multiple US federal government agencies. He was instrumental in the design build project delivery of the US consulate at BKC, Mumbai, and held leadership roles in the execution of DV Works Goregaon, the first IGBC Green Homes rated residential building of Maharashtra, and Omkar Altamonte Malad, one of the largest residential development of Mumbai suburbs. Yogesh presently heads the development department for the western regions at RMC Co. Over to you, Yogesh, sir.
Thanks.
Thank you.
Thanks.
Thank you. Thanks a lot. Parikshit, can I proceed?
Yes, sir. Yes, sir. Please, please.
Okay.
Thank you.
Great. Thank you. Thanks a lot. So, friends, the topic that I was given was construction/project management of tall buildings. It's very difficult to fit this in a hour's time, but I've tried to do as much justice as I can to get you acquainted with what you're going to, face in the field when you pass out of college. Typically, when I sit on these presentations, I always wonder, or kitna slides hai? So to make it easier for you, I'm already letting you know it's only 49 slides, and there's a slide number on the right-hand side bottom, so you'll always know how many more to go. So to begin with, project management is a multifaceted discipline, can be utilized in any field. But as far as construction is concerned, it's always we look at 3 parameters: time, quality, and cost. The 4th parameter that we never really pay attention to is EHS, health and safety. But nowadays, a 5th dimension has been added to it, sustainable construction. When I mean sustainable construction is not about getting IGBC or USGBC certification for your building, but about how you go about with your on-site construction processes to make them sustainable. For example, we at RMZ have now started tracking the amount of electricity that we consume in construction of a building on a per square feet basis, similar to the amount of water that we are consuming per square feet of construction, or the amount of debris that we are generating per square feet of construction. So it's a multifaceted discipline. And I'll take you briefly through some of these, but most of my presentation is based on, technological advances available in construction or project management, and the various tools that we have at our disposal, which you guys will definitely be using in future as and when you hit the field. So going back to the previous thing, we always talk about projects in terms of their quality, the time taken to take the product to the market, or the cost efficiency on a square feet basis. But there are so many other aspects that overall lead to the project management criterion of a particular project. I mean, it's very, very akin to the iceberg. What you see at the top is probably 1/5 of what all processes that go into it. So I'll take you touch base on a few of these. There are quite a few videos that I have that I would like to show you, permitting time as well as my internet connectivity. Before we get into that, I would like to quickly take you through the traditional versus modular construction techniques that we employ. You will be eventually designing your buildings to suit these construction methodologies. This is not something just the guy in the field or the civil engineer or the project manager handling that project has to worry about. You will have to cater, you'll have to design to accommodate these newer techniques. For example, the 2 at the bottom that you see on your screen, 3D printing or top-down construction methodology, very interesting. I'll quickly take you through this. The first 3, of course, are RCC, that is the standard way of doing buildings. Steel, slowly India has started warming up the concept of constructing buildings in steel. And prefab, there are quite a few buildings in Mumbai today which have been built with the prefab construction methodology, with some inherent flaws that we need to overcome over a period of time. Okay, so what happens to steel buildings is we get a very good speed of construction. They are lighter in their dead load, so you have lesser loads on the foundations. Most of the fabrication is done in a factory-like environment, so you have good tolerances, good quality control. The only issue, or the biggest issue with steel buildings, is their lower fire resistance, and the remedial measures that need to be taken to make these buildings fireproof are very costly. In certain cases, cost inhibitive. At the same time, we have a lesser skilled manpower or technical know-how to build tall buildings in steel. But going forward, I feel this would be the technology of the future. The pictures you see here, the one on the top, everyone knows that, the Burj Khalifa, or the one at the bottom, the Empire State Building in New York. These were built in steel. I mean, Empire State Building stands tall, both literally as well as figuratively, for over 100 years in New York downtown skyline. So it's possible to build high rises with steel. Some of them have stood the test of time. The one you see on the right hand side is a photograph of a building called the Shunhing Square Tower. It's in Shenzhen. Its claim to fame is it was 3 floors that were constructed per day. This is possible only with a steel building. India, like I said, is slowly warming up to this idea. Eventually, you will be designing buildings in steel. Prefab buildings. Again, what happens here is basic components, columns, slabs, wall panels, beams, anything that you can think of, even the facade elements, they all are fabricated in a factory-like setting. They are precast, brought onto the site and assembled. It's more like a Meccano or Lego blocks kind of construction. Only issue here is the construction joints. The treatment thereof has to be done extremely carefully. Few projects that I mentioned about in Mumbai have failed for the reason of their inability to stop the water ingress into these buildings. Very large projects, but unfortunately, the remedial measures cost probably half of what the original construction costs were. This is a very interesting building. You'll find this on YouTube. You should really check this out. This is called the J57 Mini Sky City. It's in Changsha, Hunan province of China. Again, built in only 19 days. When I say built, it was assembled. So all the components, there were about 3,000 odd modules or components that were, brought onto site and erected. Time frame of just 19 days. That's why you see the number of tower cranes, 1, 2, 3, almost 6 over here, climbing tower cranes that were required. Imagine the amount of logistical nightmare it must have been for the guy on the site to receive all these components in a particular sequence and erect them. From an architectural standpoint, you might notice not much of a scope for any facade elements or elevational treatments, just a plain blank building. But that's something that's coming up. I mean, eventually these buildings will catch up. Another similar building is this T30 hotel. It's probably 2 kilometers. I've been to this site. It's probably 2 kilometers from the building that we saw on the earlier slide. It's 30 floors and now we are coming down to hours. It was installed in just 360 hours. It's a hotel building again. For whatever reason, both these buildings are unoccupied at this point of time. But that's not the point. We are looking at construction technologies. This is what is possible. This is how time can be saved. Look up for broad sustainable building group when you get a chance. You'll get good information. Not to be left behind, this is again a building done with prefab construction technology in India. This is in Mohali, Chandigarh, not a very good looking building. You all will agree, I believe. But again, erected in just 48 hours flat. It's a hotel building. Okay, prefab, there are certain components that you will have to account for when you get to the sites. I was talking about sustainability in construction, not a sustainable building, but sustainability during construction processes. We want lesser amount of concrete waste going to the landfill. So typically on our project sites, what we do is, this formworks for stormwater drains or precast stairs we have the molds ready. We do not fill them, but any leftover concrete, provided it is the right grade, of course, goes into this preformed formworks, and you have a good quality product. And at the same time, you're not wasting that concrete. Wasting that concrete is not just the money that you would spend on throwing it away, but it's also to do with the landfill. So the green building processes that go on site. Before we move on to the next technology, let me just quickly summarize the construction time and cost. How do these buildings differ? So theoretically, I've taken a building with about 14 stories, 3 basements, foundations, and if you see the RCC column, you can finish the structure in probably 24 odd months, about 2 years, including excavation. The same building in steel can probably be constructed in 17 months. Again, this is very theoretical, no, just an exercise done so that you understand the difference. A prefab building could probably be completed in 20 months. So very well clear that steel building would be the fastest one to be completed. But when we move on to the cost side of it, if we take the RCC building as a baseline for our cost, the prefab building is probably 20% over and above the RCC building cost, whereas the steel building can go as high as 25% more than a RCC building. 3D printing. Okay. You all, I'm pretty sure, are well versed with the technology. It has been used for multitude of products, but it has entered the construction industry as well. At this point of time, there's not a single building in India which has been constructed with the 3D printing technology, to the best of my knowledge. But sooner or later, this is going to be reality, and you, within the next 10 years of your career, would be designing buildings that will be 3D printed. Let's quickly look at, I have a nice video, I'll show you a few of those. Good speed, highly mechanized operations, very safe for workmen, but the technology is still in its infancy, and you have to really tie up with someone who has a patent for these kind of systems. So the costs at this point of time are very high. Full-fledged buildings have been built in the US as well as in Abu Dhabi. They call it low-cost housing, but they could very well certify as a nice villa somewhere in Lonavala. Here's a video that was taken at IIT Chennai. So this was a project by PhD students. One of them is an architect, the other guy is a mechanical engineer, and the third guy is a civil engineer. And they have devised this, 3D printer using concrete. So now the civil engineer comes into play, where you have to design the mix of the concrete that is being, laid out by that nozzle. This video was probably taken in second half of 2019. And the students, they were aspiring that by 2020 they would probably have at least individual toilet units built out of this technology for the rural areas. So the key you see here is that the mix is very pliable. At the same time, as the height of the structure goes up, the lower layers solidify and they're able to take the load of the upper layers. Okay, the next one is the top-down construction methodology. As the name suggests, the higher floors are built first, and as you keep going, you come down to the ground floor. Very mechanized operations, very high speeds of construction, extremely safe. I have a video, you will very well understand. Again, this is a patented technology, and the costs are exorbitant, at least at this point of time. So I have a case study here for you guys. These are 2 buildings. They're called SRR3 and SRR4. They were built for Intel. Intel had in the project brief said that they wanted this construction methodology to be used. And this is probably the first and only building in India to be constructed with the top-down construction methodology. Not very large buildings, about 0.6 million square feet each. They are in Bangalore. So this is an actual site photograph. These are the three cores which become very critical in this construction methodology. I'll explain to you how. So this is in the Sarjapur Ring Road area in Bangalore. That's why Sarjapur Ring Road, SRR 3 and 4. The architects were Thomas Associates, structural consultant was Thornton and Tomasetti. And the design build contractor was Shapurji, who had in turn tied up with ACOS Construction, who were the technology partners out of New Jersey, USA. Shop Architects US again did the interiors and facade. AKF were the MEP and fire protection engineers. So again, a short video. I'll pause as we go ahead and explain. Parikshit, just to make sure I'm audible and you're seeing the screen, correct?
Yeah.
Thank you.
Yeah.
Okay. So this is excavation happening basically. This is an animation. The foundation for the cores are laid. The cores are taken all the way up to the top of the building. In similar fashion, all the cores are finished. Now what you see is the formworks being done at the ground floor. This is a steel decking basically. So you see the entire slab is all in panels. This is concreting being done. These are the jacks to lift up the slabs in their location. So what happens is all these slabs are elevated by a height of about 1.2 meters, so that all the ceiling suspended utilities are installed at the ground floor itself. Extremely safe for the workmen. Now this being the terrace slab, all the rooftop equipments have also been placed on the top, and the slabs are incrementally taken to their position and locked into place. So the terrace slab is done. Subsequently, individual slabs are raised into position. If you'll notice, the facade is also in position. And in a similar fashion, you keep coming down. That's the reason top down. Typically, containers with all the interior furnishings, fixtures are placed on the slabs itself and put into position. Eventually, all your lifting equipment is taken out of position, and your building is complete. Basically, no one had to go to the top of the building. There were no, issues with the height restrictions, working at height. Now, what changes the game here is the costing. If you look at the cost at the bottom, 13,745 rupees per square feet of construction. That is probably thrice of what it would cost for a RCC building with all the finishes, with all the MEP in a city like Bangalore. That's where it differs. Okay, so after having covered the construction methodologies, let's move on to the technology side of construction management, how sites today or how projects are differently handled. There's a lot of talk about digitalization in construction, and we had a well laid out time scale on how things would eventually get into construction. I mean, today we are probably the industry that lacks the most. We have been doing things like we have been doing for the last 100 years. Eventually, the goal is to learn from the automobile sector or maybe a FMCG sector, make it a conveyor belt kind of industry. So we'll look at some of the options available today. So why focus on technology? So obviously to accelerate the construction deliverables, manpower is a big issue today. Reduce our dependency on manpower, increase our productivity, and so on and so forth. Real-time monitoring of all the parameters of the project. Almost have a dashboard kind of, for all projects, and sitting at one location, you can virtually run your projects. Drones, typically you'll find them today doing marriage or wedding photography, but we have been using them extensively within our projects, not only for construction monitoring, but also surveying. I'll show you a few images of the surveys done by drones, and you'll be really surprised. I mean, the human intervention or the manpower requirement with these inventions has literally gone down by multifold. So we are using them for building surveys, construction site inspections, project progress reports, a live feed from sites, promotional photography or marketing collaterals. That's another aspect. Here I might have to get out of the screen. Okay, for some reason this link is not working, but we'll come back to that. I have this covered in one of the other slides as well. This is one of our actual project sites. Now, nothing great. I mean, a camera installed on a neighboring building can probably, give you the same visuals, but it's not limited to that. The access that I have used for this particular application, as in for our presentation today, is a limited version, but I can actually zoom in. If there's a rainwater, I can calculate the quantity of rainwater that has accumulated. I can check the sizes of the foundations in plan, of course. I can check the column to column spacing. I can check the sizes of the columns. So someone sitting in the head office or remotely from anywhere, he can, do multiple things which were previously unheard of. Again, this is a survey. Sorry. It's a very large scale of a huge area. This is all done by drones. The count of the trees is accurate. I mean, there are a few structures. I'm not able to zoom in further on my screen right now, but if I go through the application, all the gray lines that you see are actually spot levels. These roads are existing roads that were captured by a drone. The trees, the accurate count was taken by the drones. The drones have a capability not only to do it in plan, but some of the peripheral trees, we could even calculate the girth of those trees. So these are the possibilities today with the drones. Another concept that you're going to be dealing with in future is orthomosaics. Again, extended application of basically drone photography, but more for as-built or rather as-built surveys, or maybe eventually how do I put it? Probably let's leave it at as-built surveys at this point of time for the want of time. Same thing with 3D laser scanning. We are actually utilizing this technology wherein we go in and buy old properties, and it's not physically possible to do a survey of each and every floor to probably inventory the amount of furniture or the equipments or the whatever that is in that building. With drones and through 3D laser scanning, this has become very quick and easy today. Okay, this is something very close to my heart. I'm driving this very extensively in my organization, and I have a few slides that I would like to take you through. This is the future, guys. I mean, building information modeling. You are eventually within the next few years going to be working on BIM models rather than the 2D drawings that you might be used to. So BIM modeling, not only for class detection and resolution, which is what you will see here, ensuring all the services, there's no clashes with each other, but also for BOQ generations and as-built model generations. But there is more to it than just this. Okay, so with the translation from 2D to 3D models, you can also add the time component, as in every project has a schedule, be it in MS projects or P3 Primavera. This can be integrated with the BIM model. And for example, let's consider this yellow pipe. If you can see my cursor as your chilled water piping. If this is supposed to go in September of 2021, as and when it is installed, it also gets shown on your BIM model to actually do your physical progress tracking. There's a fifth dimension to it. It's called 5D, and you can actually add the cost parameters to your BIM model, wherein you can devise your contractors, subcontractors, contractors payments based on the amount of work done just through the BIM model, or you can check on your cost to date through a BIM model. I'll show you a few simulations, and that will make it more clear to you. So when do we start with the BIM modeling? So it has to start right at the conceptual stage. You move on to the detailed design, you go into design documentation, further you use the model for simulations, whatever, CFD analysis for wind forces, design of your facade, be it for glare, be it for daylighting, be it for sun shading. Eventually you hand over all this to the site team or the project team for construction, who uses it for fabrication of critical components. It is used in the construction logistics, the number of tower cranes required, what is going to be your access while you are in the foundation. When you're digging, how is your access going to be when you are above ground? You add the time schedule to it to make it a 4D BIM model. You add the cost parameter to your model to make it a 5D model. And eventually this is what you hand over to the operation and maintenance team for their usage. It doesn't stop with the operation and maintenance. I mean, we at RMC, we are looking at all the way until 50 years from now when the building will actually be demolished. And that's where we find use in this usage of BIM. Before we move on further, let me quickly take you through this. I'm not sure whether this is covered in your curriculum or you have learned it elsewhere. But let's assume you guys have been interested with building just a 20-seater conference room, and the design brief says you need to have chairs. So during the concept presentation, you just present a chair, and this level of BIM modeling is called LOD 100. A chair is required, a chair has been plonked over there. At the LOD 200 level or the design development level, you say now this is an office chair, and it has certain other parameters, the width, depth, and the height. You move on to the next level of detailing, LOD 300, which is your design documentation. You further go ahead and say, yeah, it's an office chair, it has armrests, and it is movable on caster wheels. You pass on this to the construction team. Now with architectural selection and everything, there's additional information available to this model, wherein you say it's Feather Light is the manufacturer, Mira is the model. Eventually the site procures it, and it is passed on to the facilities management team, which is LOD 500. So wherein additional information is available, the date of purchase. So from the date of purchase, you can get the warranty period. Imagine if this were, instead of chair, this were a fire pump, or imagine if this were a critical component like elevator. So all that information residing within the model and available at the click of a mouse, that makes a lot of sense. Okay, so here's a 4D simulation. 4D is wherein time component has been added through the 3D BIM model. So I'll quickly run you through that. The video does not have any audio. So if you notice at the bottom, there's a time scale. And as with the passage of time, you can see what all activities are to be completed to finish this project on time. So it's a stadium basically that is being built. So if I read it, it's something like April, it says at the timeline here where my cursor is. So in the month of April, this is where, if everything is going right on the project site, this is where the project site would be. So that's the simulation basically. But this is just step one. The next video is even better. So with the passage of time, it's showing you what all activities get completed. Okay, so this is another project. Now, none of these videos are high-rise buildings, but it does not really matter. What I'm trying to convey here is the importance of BIM. This is a large video, so might take some time to load. But what we have here is two screens, one on your left and one on your right. So the right screen is going to show you the baseline schedule, and the left screen at the simultaneously is going to play the current schedule. So the baseline could be something that the owner agreed with the contractor while signing the contract, that this is your time frame to finish the project, and the left screen is going to show us where the contractor was at any point of time on the time scale, which is at the bottom of the screen. So these are the possibilities with the BIM models. So we can take a snapshot at any point of time. So this says somewhere October of some year. And at that point of time, according to the signed contract, this is where the contractor should have been. Here he is slightly. Okay. So facade was to be completed for 6 or 7 odd stories. Here he is lagging behind. As per the contract agreed upon with him, there were 2 tower cranes. He has provided those. 2 boom placers. He has provided those. So these are the kind of possibilities that exist with the full-fledged BIM model. Okay, now friends, this is the future of architecture. This is the future of construction. This is where the industry is heading. You need to, I am unsure of your curriculum. I am unsure of what all is taught at school to you, but this is where you need to pay a lot of attention. You need to upgrade yourself to be able to work on BIM models. Now, the National Building Code of India does specify asset and facilities management as its chapter in volume 2. The original BIM standards are based on the National BIM standard of US. BSI standards, as in British courts, also talk about COBie. So what is COBE? COBE was a term coined by a gentleman by the name Bill East of the US Army Corps of Engineers. What it stands for is, you have to read it slightly differently. What it means is construction team to operations team building information exchange. I have been involved in handing over quite a few projects, and what we typically do is make 3 sets of all the drawings in the largest format possible, copy all the product data, copy all equipment list, copy all in 3 sets, put them into big size ring binders, probably pack it in 4 or 5 huge boxes and hand it over to the FM team. The FM team really does not have the time or the interest even to go through all those documents. Now imagine if I were handing him a BIM model with all this information residing within the model, wherein he can actually walk through, or he can click on any particular piece of equipment and all the data is available to him. So these kind of standards, COBE standards rather, they specify what all information needs to go into the BIM model, which is a 6D model now. 6D is something that you hand over to the facilities team. So we started with 2D. 2D is your regular drawings. If I have to look at the plan and I have to imagine the section, or I have to look at another drawing to look at the elevation. 3D is the BIM model itself, all the systems, architectural model coupled with the MEP systems. 4D is BIM model with the time schedule included. 5D is 4D plus the cost included, and 6D is all this equipment details. It's not limited to equipment, could be anything. The manufacturer's info, equipment details, product data sheets, warranties, preventive maintenance schedule. This is 6D basically. And eventually this is going to turn into a digital twin. What will happen further, which we are trying on an experimental basis, is inclusion of a lot of IoT based sensors, wherein we have real-time feedback of the actual building from the BIM model. Course correction of systems that are underperforming or not performing at all can be done at a click of a mouse right on your screen, right on your PC, laptop, whatever, and the effect happens on the actual building. And this is not fiction. This is actually happening. You need to really gear up yourselves for this technology. So, okay, so we spent a lot of time on BIM. VR meetings, it's becoming common today with the BIM models that we have. At this point of time, we have some rudimentary BIM models, but with the COVID pandemic, in the last probably 6 months, I've spent more time on a Zoom or MS meetings, also on BIM 360, wherein we are reviewing models actually sitting at 4 to 5 different locations. This is a reality. Mobile technology, this is catching on pretty soon. Now we are almost eliminating pen and paper from our construction sites. Wearable technology, not limited to your MI band or the iWatch. Today, even hard hats used at construction sites, they have become smart. They not only register the workman's identity and presence on the work site, but there are sensors embedded in his chin strap, the strap that goes across his chin to hold the smart hat or the hard hat on his head. They're embedded with sensors to make sure that he's actually wearing a hat. And secondly, there are also sensors to check his pulse and heart rate. It's slightly difficult implementing this in India. We have spoken to a few companies, but the cost, just in case if the workman decides to take it with him, he has no use outside the construction site. But that's the reason we are kind of holding on to this. But this technology is coming. Now there are a lot of CM/PM tools about all this movement from BIM 2D all the way to BIM 6D. We are talking at presently to two of the major manufacturers, RIB and Procore, wherein all our processes are digitized. We are looking at their compatibility with our accounting software like SAP. But this is coming. This is coming pretty soon. While we talked about all of these are foreign products, we have actually tied up with a company called Impulse, based out of Chennai, a couple of enthusiastic IITians with no knowledge of construction, but they have taken up the challenge and they are providing us services wherein all our construction site operations are, if not 100, at least 75% digitized today. So anything you take with the project, be it contractors, daily reports, material indents, labor attendance, their safety integration, quality reports, BOQ generation, our costing and budgets, project scheduling, any documents, be it specifications, drawings, minutes of the meetings, RFIs or issues raised, they all are digitized, and at the project site, based on RBAC stands for role-based access control. So a site supervisor probably will have access to the RFIs and quality-related issues. The project manager will have access to the budget and BOQs as well. But this is all possible just on a screen, available on the screen as well as on the smartphone. These are some of the reports that we generate. So S-curve is pretty normal. So the blue line here you see is the projected delivery of the project, 100% completion sometime in August of 2021. And the green line depicts how we are progressing. Now this progress could be measured in multiple ways. Cost to date, concrete poured to date, number of stories of floors added. Now you see a small dip here. That is all because of COVID. And this is our course correction in orange, how we intend to correct course and probably finish maybe almost 9 months later. But this is again out of the software, Impulse. Data in multiple formats is available, bar charts, pie charts. This is for multiple projects. This is more of a portfolio manager. So these are 1, 2, 3 different projects. Someone sitting at the head office at a very senior level. If the needle is in the green, he does not really need to pay attention. Once it starts moving clockwise, that's where he needs to get involved, look at what are the underlying issues. At the site level, quality inspections or RFIs, they're all being done through mobiles, the Impulse app. So now there's a timestamp, there's a authentication on who has entered this data. So those kind of discrepancies are taken off. And everything is real time. Even if someone is entering the data in the basement, for example, where there is no mobile network, as soon as he comes into the network, the data that he has entered gets into the server and is uploaded, distributed to the requisite parties. Let me quickly take you through a few photographs on. I'm not an architect. I'm a site guy. So let me tell you what we had to do differently from what the architect had suggested on one of these projects. This is a project in Mumbai, somewhere in Malad, 4 towers, high rises, 45, 51, 53, and 56 stories tall. 2 of the towers have been completed, other 2, this one has been topped out, the 3rd one is still under construction. Okay, so these are some of the site photographs. Okay, as we go taller, it becomes increasingly critical in taking the men and material to their requisite work locations. So, okay, here we go. So this photograph is taken from one of the wings of a completed building. Here, work is happening at these locations. Same thing here. Okay, this is what I need to bring to your attention. Can you see my cursor? Do you see the band? Okay, the band also has a notch. Now imagine the life of these three guys sitting in that gondola for 8 hours a day. So as we go taller, it becomes increasingly difficult to manage, these kind of projections or notches. So that's something you might have to, you might bear in your mind. Productivity as well as safety goes down. The time taken to execute these kind of intricate architectural details. These vertical posts that you see here, these are for the glass railing. So glass is to go between the two posts. Now, the design was such that we could never, though we have a balcony, the guy here is standing in a balcony, we could have very well gotten the glass inside this apartment and installed it from standing within the balcony. But somehow the design details were such that we had to lower the glass from the top floor for it to be installed in these locations. So again, a bad design, bad detailing. Okay, this photograph on the top I have chosen for a particular reason. As we go taller, what we did on this project is we eliminated most of the block work. What we did is we instead moved to non-structural walls. Since this was done with aluminum formwork, all the internal partition walls within the apartment got cast simultaneously. So we actually limited the amount of block work, though you see some here, it was minimized. You can imagine the amount of materials that has to be brought into this location. He's punning this with the gypsum plaster, and the amount of waste it creates, which again has to be carted all the way down to the ground floor and then taken to a landfill. Another example is on this left-hand side photograph. Not a very clear photograph, to be honest with you, but you can see the UPVC fins. The material was UPVC. These were fins to cover the plumbing shafts. Now, originally, the architect's intent was to have shafts running vertically all across without the bands being streamed. Now, you imagine having to hang from 53 floors above ground and trying to install these fins, and later on probably maintain them. So we had to change the details. We had to go floor to floor, and so we could install them from within the shaft rather than having to do it from the external face of the building. Just bringing to your notice a few things wherein design plays a critical role even in the site execution. This is the last slide I have, the 49th one. I'm going to leave you with this thought. Today, every other building is going for LEED certification. It is becoming a norm. You need to get acquaint yourself with these requirements. Now, LEED is becoming standard. We have moved on to WELL, where the requirements are even stringent, and we have an aspiration to have at least one building that is net zero. So net zero could be net zero carbon, net zero water, or net zero energy. We are working on that. This is the future, guys. This is what you need to equip yourself for. That is all I have. I'm open for questions. I hope I did justice to my 45 minutes. Parikshit, over to you.
Yes, sir. Yes, sir. Definitely. It was a nice presentation, and definitely I've received some of the questions. Any questions from you guys directly, or I've received a few questions. One was, am I audible? Hello?
Hello, sir.
Yeah, am I audible? Hello?
You are. Yes, sir.
Yeah. Okay. So somebody is asking the question.
Hello, sir. Can you hear me?
Yeah.
So I had a question. So you were talking about the manpower that is required for
I'm sorry, we are losing you.
You are not audible, Muskan. You are not audible actually.
You can even type in the.
Yeah, you can send a message in the chat box, or send it to me. Hello. Acha, so meanwhile, I have received one question. So what are the advantages of top-down construction methodology in terms of conventional method?
Okay, advantages are multifold. Um, First things first, I mean, safety is a big issue at construction sites. I mean, we have unskilled labor coming from the village. The guy has never probably even worn chappals in his life, and the first day of his, on the job site, we make him wear a 2 kg boot, long pants, a hard hat on his top, on his head, and the level of skill available in India is um, very dismal. Now, in the top-down construction methodology, we saw the. I'm sorry, is someone trying to speak? Okay. In the top-down construction methodology, every slab is constructed at the ground floor itself. It is elevated by about a meter or two, wherein you install your, ceiling suspended services. You install your facade, and then you lift it into position. It's only a matter of cost that makes it unviable.
Okay, right. Uh, I've received is for the regular maintenance, so like for the facade cleaning and uh, uh, apart from the construction methodology, what are the measures we'll have to take into account for the regular maintenance of outside facade cleaning, then your aviation light maintenance and all?
And so like my
Muskan, you are not audible, or maybe Muskan, can you please type your question in the chat box?
So she's already typed it in the chat box.
Okay, I'll go through it. So the previous question was the maintenance issue. So what are the measures we'll have to take into account?
Correct. I mean, whenever you have a glass facade building of any height for that matter, building maintenance unit is always designed with the facade. It goes hand in hand with the facade design that is installed on the top of the building. So that's a prerequisite basically.
Right. So like a cradle runways and all.
Correct. And typically these are all motorized with a divot arm sticking out of the building, and the
Yes. Right.
cage can be lowered up and down.
Right. Muskan's question was scope of 3D printed buildings in India, considering there is no shortage of manpower as compared to the other countries.
Absolutely correct. We have ample manpower, but no skills whatsoever. No skill. With that said, I'm pretty sure Muskan, within the next 10 or 15 years, if you decide to take up buildings as your line of work and not something like landscape, I'm pretty sure you will be designing for a 3D printed building in India itself.
Absolutely.
We are an industry who are the last ones to adapt to any kind of technology, and the major reason for that in India is the skill levels available in India.
Right, absolutely. Okay, I hope Muskan you got the answer. Any other questions, guys?
So, Vaibhavi here, I have a doubt. So, regarding the 6D, sorry, the simulation of where the person has to keep updating the software as to this work has been. So, at what intervals is it done? Is it done on daily basis, or is it a weekly thing? How does this really work?
Right. So what happens is once you have built the 3D model, it is approved, it is handed over to the project team for the execution. At the project level, the schedule is incorporated into it. So you have the 4th dimension. The costing is added to it, which is the 5th dimension. So the updates could be at any interval depending upon the scale and the speed of the project. The snapshots can be drawn at on a weekly, fortnightly, or monthly basis. The monthly report could give you the contractor's billing even, or the cost expended. Typically, it's done on a monthly basis, but updates can be done at the discretion of the site, which is typically done on a weekly basis.
Okay, sir. Thank you.
So I have a question. So as an architect in the entire team of construction, the model comes from us, or the design comes from us, and there's another separate team who makes and works on the model, because it's like a common server, all the like the stakeholders are interacting with the same model. So as an architect, what exactly should we focus to get into the BIM technology?
Correct. Very good observation. At this point of time, we have had to appoint third party, BIM model operators for us, because some of the consultants are not working on BIM, or if they are working on BIM, they are not adept with the coordination. Eventually, it is going to be the project architect's baby, wherein the consultants will upload their models on BIM 360, and the project architect would be the owner or moderator for that model until he hands it over to the project team for execution.
Okay, sir. So basically, we are the ones who will be compiling and monitoring the model, and the other teams will just make their updates.
That is correct, because you are designing the building.
Right.
They are designing the systems to suit your configuration, your building parameters, right? So they will be, for example, the fire protection engineer will create his model, and he will pass it on to the project architect, who in turn has to incorporate it into the main model and ensure that there are no clashes.
Understood. Okay, sir. Thank you.
At this point of time, we don't have architects who want to take over that responsibility. So we have to appoint, consultants who are collecting each individual model, be it the architectural model from the architect or the services model from the services consultant, and putting it together and providing us with reports on clashes, or they are going further and providing us BOQ quantities and all that. But the price for these services is very minimal, and that's why we don't mind it.
Understood, sir. Thank you.
Right, very true. Actually, nowadays we have a BIM specialized architects also in the market, so who actually takes care of all those coordination.
Yeah.
Very true.
But within the last 5 years, probably in the next lecture, you can ask this question to architect Anuja. We have seen a huge resurgence, surge in the BIM requirements.
Exactly.
Most of the clients, they want BIM models.
Right. Okay, guys. Any more questions? Any more questions? Okay, I think then we can move ahead to our next session. Yeah. Thank you, Yogesh sir.
Thank you, Yogesh. Thank you, Parikshit, and thank you to all the student friends. Thanks a lot for this opportunity. Good luck.
Thank you. Thanks a
lot. This is Vineet Mirkar.
Principal. Yeah.
Being here.
Vineet sir. Hello.
Yeah.
Yeah,
Hello?
we can hear you. We can hear you now. Yeah.
Yeah. So I just wanted to update Yogesh that for last 3 years we have been looking at these kind of futuristic requirement of architecture profession. We've already included the BIM learnings in our curriculum. So there are elective programs we are conducting. There are certain kind of college projects programs we are conducting on a beam level where we are started doing the training for and exposing the students to this ecosystem, because that is the future of the architecture profession eventually, and how we will be able to integrate that and make sure that their intents and their detailings are attuned to this coming technology has been taken care. We are exploring, but as what you rightly said, we in India is still not under a 2D BIM level also. The world has reached to 6D, but we are still under a 2D. So we have to move faster. And I guess the student will be the first people, because they are very tech savvy people. The moment they adapt better, the architects where they will get employed will get a confidence of start working on these models, and then maybe our future architects will be able to work on these things efficiently. So we are trying our bit very correctly to get into this already, and I guess these kind of exposures and the kind of what we say is getting the like you people come and say that this is what is required. The students also get motivated that yeah, this is what we have to concentrate, focus, and learn very correctly, which the college is offering. So thank you very much for getting this awareness to the students as well as to the faculty. Thank you.
No, Mr. Maker, thank you. Thanks a lot for the opportunity. Actually, I am not sure whether I did justice to the topic that was given to me, construction management or project management, but I kind of focused on, um, topics that they should be aware of. So once again, thank you for the opportunity. Thank you.
Yogesh, it was perfect. I mean, that's what architecture student needs to understand. And I think you have hit the nail right at the point. I think it was
Yogesh, Chris here.
Yes, great.
No, it was very nice, as Anuja said. And actually, we are not here to give, the last details of the process of project management and construction methodology. It is to expose, because in 45 minutes or 1 hour, you cannot teach anything. It is just to give highlights. It's a trailer,
Correct.
So, and that was very nice. I think all the students really got a flavor of what is new in the field, which is what is required today.
I hope so.
So that was nice. Great going.
Thank you.
Absolutely, absolutely. I think they were looking at the same perspective, because they are eager to know about the latest technologies, and those technologies are now available in India, as you said, for the Bangalore projects and all. So that was a great thing, for them to understand.
Thank you for it.
Thank you. Thanks a lot. Okay, so
I'll share my screen.
yeah, so we'll move ahead to the next topic. Our next lecturer is architect.
Do they
Anuja
need a
Samant.
break of 2-3 minutes by the time I share my screen?
No, I think we can continue, because
We can continue,
they
right?
are with the So just a moment. The screen share is available.
Can you see the screen?
Wait.
Not yet.